Okay, let's see if we can help you guys figure out how to determine if it's an arithmetic or geometric sequence, how to find the recursive formula, the common difference, and the explicit formula. Okay, so the first thing you're going to do is you're going to find out if they have a common difference, and you're going to do that by doing some subtraction. So 43 minus 38 is 5. 53 minus 48 is 5. 48 minus 43 is 5. 58 minus 53 is 5. So there's obviously a common difference here. So if there's a common difference, that means it's arithmetic. What it means when we have an arithmetic sequence is that it's a linear function. So we're going to use our standard form of an equation for a line, which, if you remember, is y equals mx plus b. So the nice thing about arithmetic sequences is the common difference is your slope of your line. So it's your m. So we can go ahead and insert that. But now we need to find out what b is. The first number in your sequence is going to be your 0 term. So this is our term 0. And what that means is that when x is 0, that is what is y. So let's put those in. Y is 38 when x is 0. Now we're just going to solve for b. So 38 equals 5 times 0 is 0 plus b. So 38 equals b. Now we're just going to plug that into the equation that we already started with and get y equals 5x plus 38. That is our function. That's going to be our explicit formula. Okay? Now, for our recursive formula, all you're doing is telling me if I am looking for the nth term, how do I do that? And you're going to use the term before it. So you're going to tell me that take the n minus 1 term, and in this case, we're adding 5. That is my recursive formula. So now we have our explicit and our recursive formula. So now let's try a geometric sequence. With a geometric sequence, we're always going to get an exponential function. So that's an important thing to remember. This one's kind of a complicated one, which is why I picked it. I want us to go through it together. So just looking at it, it's kind of hard to see what's happening. But if I put a 1 over this 3, I can see that on the top, all that's happening is that my sign is changing. On the bottom, I multiply by 25 each time. I think I'm missing a number here. Let me check. I'm missing a number. So let's start this one again. This one should go -3, +3 over 5, -3 over 25, +3 over -125, or positive. That should be a positive.
Did you get that?
Sorry, I got interrupted for a second. So let's keep going. So then we would have a -3 over 625. Okay, so like I was saying before, if we put this over a 1, the top, all that changes is the sign. And what that means is that there's going to be a -1 involved. So let's go ahead and put that in there. On the bottom, we multiply by 5 each time. 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. So we're multiplying by a 5 on the bottom. Okay, so that means we definitely have a geometric sequence. We're multiplying by the same thing each time. Now, if you remember, our standard form of a exponential function is y equals k, which is our scale factor, times a to the x power. So when we're dealing with these geometric sequences, our constant multiplier, this negative 1/5, becomes our a. So it's going to go right in there. So we're going to get y equals k times a negative 1/5 to the x power. Now, just like we did with the arithmetic, we're going to take our 0 term, this negative 3/1, and we're going to put it in for y, and that's what happens when x is 0. So we're going to get a negative 3 equals k times a negative 1/5 to the 0 power. If you remember from our properties of exponents, anything to the 0 power is just 1. So we get a negative 3 equals k times 1, or k equals a negative 3. So we're just going to go ahead and we're going to plug that back in to this formula right here that we already started. We're going to get y equals a negative 3 times a negative 1/5 to the x power. Now, if I'm doing my recursive formula, what happens? If I'm looking for the next term, I need to take the term before it, and I just need to multiply by that negative 1/5. And now I'm done. So hopefully that helps. If you still have questions, let me know, and I will do my best to help you. Thanks.